way in which we can write square roots. This can be written as 5 raised to 1 by 2. How can we write the cube root of 7? It can be written as 7 raised to 1 by 3. If we have something like the nth root of a, it can be written as a raised to 1 by n. This is a very important concept you need to understand in order to solve fractional exponents problems. The nth root of a is equal to a raised to 1 by n. But just this concept isn't enough. A raised to m, the whole raised to n, is equal to a raised to m times n. This is called the power law. Understand it well. A raised to m, the whole raised to n, is equal to a raised to m times n. These two are multiplied in the power. So if we have something like 5 raised to 2, the whole raised to 3, it can be written as 5 raised to 2 times 3, and that equals 5 raised to 6. Now what kind of problems can be asked in the exams? Maybe something like 8 raised to 2 by 3. 8 is the base and 2 by 3 is the fractional exponent. How do we simplify this? It's interesting. We can write it as 8 raised to 2 times 1 by 3. It's the same. 2 by 3 is the same as 2 times 1 by 3. And based on the power law we saw, this can be written as 8 squared raised to 1 by 3. This was in the a raised to m times n form. And this is in the a raised to m, the whole raised to n form. As 8 squared is 64, this will equal 64 raised to 1 by 3. And guess what this is? This is in the a raised to 1 by n form. This is the cube root of 64 and that is 4. This weird looking number was reduced to an integer using two basic concepts we learned. Here's another one. The square root of 64, the whole raised to 1 by 3. Try it out. What is root 64? It's 8. So this will be 8 raised to 1 by 3. And this is the cube root of 8, which is 2. The two concepts we learnt are more than enough to solve problems based on fractional exponents.